All right. So in class, we did a bunch of one-dimensional work with dealing with coefficients of coefficients of restitution, etc. Okay. And just to reiterate, the important thing about the coefficient of restitution is it tells you something about the relative velocities before and after impact. Okay. So we would say the relative velocity of the final state is equal to minus the coefficient of restitution times the relative velocities of the initial state. Okay, just like that. And just to remind you, if you've got these two objects, all right, A and B, okay, as long as in your deltas you do A and B in the same order, it's fine. Okay, in other words, we could go like this. We could say VA final minus VB final is minus epsilon VA initial minus VB initial. Okay, that's totally cool. If you do it as VB final minus VA final, all right, all you've done is switched your minus sign, right? Boop, 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 boop. And it's the same equation, okay? So it doesn't matter which one you do, just be consistent, okay? A minus B, okay? Just be consistent with that, or B minus A. As long as you're consistent, it's all fine. All right. Now, with collisions in 2 dimensions, which is what I'm going to cover in these videos, we have to deal with conserving momentum in 2 directions. Okay, and so we are often going to see something like this. We'll see that we've got a PX final, which has to be PX initial, and then we'll have a PY final, which has to be a PY initial. Okay, so we'll see that sort of thing a lot. Now, what we have to do then is we have to figure out with our coefficient of restitution, does it go with the X direction or does it go with the Y direction? Okay, if we've got it set up somehow where that coefficient of restitution is dealing with both X and Y, we've screwed up. Okay, change your axis. You don't want to deal with that. All right, so let's get into this one, and you'll see how this fleshes out. All right, so the ball strikes a smooth wall. Okay, so that's code. Remember, that is code for that there is no friction. Okay, don't ask me why they put a brick wall in there. Okay, but they did. All right, and so that's what we're dealing with. Let's put a coordinate system on here. All right, X and Y, just like that. So we've got Vx and we've got a Vy. All right, and it's good in these kind of cases also, once you've established your coordinate system, it's good to go ahead and break it down into what are your X bits for each object and what are your Y bits for each object. Okay, that sort of thing. Or before and after, that sort of thing. So what we're going to do is we only have one object there. I don't know why they're being so goofy with it. Your book likes to use 1 and 2. I prefer to use initial and final. That's just a little bit easier for me. So let's do it like this. We're going to have V initial X and V initial Y. Okay, it's a 30-degree angle. So we're looking here at 20 times, for X, 20 times the cosine of 30. And the other one will be 20 times the sine of 30. All right. And once you work that out, 20 times the sine of 30 is 10. So that's 10 meters per second. And the other one is like, I didn't write it down. It's like 17 or something like that. Okay. All right. We'll get an actual number on it here in just a little bit, but for now we'll just leave it like that. And then what we want to do is go ahead and say what is our final state. So the final x is going to be whatever the final velocity is times the cosine of theta, and the final y is going to be the final velocity sine of theta. Okay, we don't know the final speed. We don't know the final direction either. Okay, so there we go. Okay, now what I didn't tell you is there's a reason that I chose the coordinate system the way I did, which is traditional. Okay, and that's actually pretty important. I didn't pick it just because it's traditional. I picked it specifically because this thing says it's a smooth wall and it's a vertical wall. Okay, since it's a smooth wall, there are no horizontal forces acting on the ball. Okay, no horizontal forces there at all, which means then that I said horizontal, no vertical forces acting on the ball, which means that the vertical component of the ball isn't going to change. There's nothing to change it. Okay, now if we did have some friction, then that friction could change it, but we don't, so it doesn't. All right, the only force that we have at work here is the normal force from the wall, and that's going to change the x velocity. So our y velocity is preserved, but our x velocity is not. So what I did then was I aligned the x and y based on what was going to be preserved. Okay, so and what was going to have to change. So our coefficient of restitution here affects the motion in the x direction, not in the y direction. Okay, so that really means that my final y is still just 10, just like this. Okay, so whatever I had here for y, that's what I've got to have there. All right, now in order to get the x velocity, what we're going to have to do then is use our equation. Now, the two objects that are colliding here are the wall and the ball. Okay, and so the wall velocity is always 0. All right, so that means my impact equation is just going to reduce to Vx final is minus epsilon Vx initial. All right, so this becomes minus 0.75 times 20 cosine of 30 degrees. That's the number I calculated in my notes. And that is 12.99. I'm going to hold on to that extra digit since this is an intermediate answer. Okay. All right, so now I've got Vx and I've got Vy. Let me go ahead and write this over here just so it looks good. Okay, now I need to find the magnitude and I need to find the angle. Okay, and so I'll let you take it from there. That's pretty easy to do. Obviously, for your magnitude, you're going to be doing this. Vfx squared plus Vfy squared. And tangent of theta is going to be Vy over Vx. Okay, so you can work those two things out. All right, and anyway, that I'm not exactly sure how you're going to have to put that answer in on Mastering Physics. So if you need a magnitude and an angle, if you need the components, whatever, it's all there for you. Okay, so now in this particular example, we ended up not really needing to use our two relationships there, but that's primarily because we're effectively treating the wall as an object of infinite mass with zero velocity. And so that changes some things a little bit. But you're going to see that come into play in the future. Okay? All righty. Let's get ready for the next one.